Hello and welcome back, guys. Today we are going to do the program for binary search. And for binary search, we know that the algorithm works in such a way that we find the midpoints for any particular array and we divide it on that basis. So for every array, if the basic condition is that it has to be a sorted array, and what will happen within your division is that the first division will be the midway. So the midway for any array is the integer division for that particular length. So here I am having the length 5, suppose. So the integer division would first get 2, and here I'll get 3 values, right? So then for again I'll check whatever value. Suppose here I'm checking for 10. So what will happen is it will check whether my value, that is x, is on this side or this side. So to check that, you will just fetch these values and you'll check that if it is falling in which particular array. So if the number is smaller than this particular value or equal to this particular value, then we'll look into this particular array. Otherwise we'll just go to the next array. Here again we'll break through the point. So here 3, so for 3 we'll do the integer division by 2. So we'll get 1. So this will be my midpoint, and based on that we'll check that 4 is not my 10. Then again I'll just switch to this array, and in the this array also I'll again break down this into two parts, so 10 and 40. Then I'll check that 40 is my array element that I'm searching for. Then I'll just return the index for 40. That is the basic algorithm for your binary search, but the condition is that you have to have a sorted array. So now let's look into what we have done. So this is the recursive method, and in the recursive method I have written a function that is for binary search. We are passing on the parameters as ARR, which is my array, the low, the high, and the X. Okay, so here for the first thing is I'm checking whether high is greater than low. So the first thing that we have to check is it is empty or not, right? So if it is not empty, then we will go inside that loop, and then we'll do mid equals to high plus low by 2, which basically means that low will always be your 0, because every array starts with the index 0, right? So we'll be having low as 0, and our high will be changing based on the length of the array. So high is our length of the array. As you can see, when I'm calling, I'm getting length of the array, and we are fetching that. Now the next thing is, once we are doing the integer division, now since I'm doing -1 here, the reason is that this basically gives me the size. So if there are 6 elements present here, it will give me 6, but to access my index I must have 0 till 5, right? That is why I'm passing on -1 here, and x is the value that I want to search for. Now once I've done this, I will get my midpoint. So my midpoint is whatever value that I'm getting. Now I'll be checking whether that particular index is storing my x or not. If it is storing, then I'll return mid, which is my index. Otherwise I will check whether it is in the greater loop. So it is if whether it is on this side. So if it is on this side, I will just fetch this array and I will change the mid -1. I will do the same thing, but I'll do mid -1. Okay, and otherwise I will just do mid +1 if it is on the greater than side. So if it is on the greater than side, I will increase the mid. So here the mid is 2, I'll increase the mid, and here the um, value is on the lesser side, if so I'll just change the mid to -1. So depending on that, you can change your mid. Okay, and after that I'm just calling the function. So here what will happen is ARR for ARR 0 and len of ARR -1. So similarly, just as I explained, you will be getting two different things. So first of all, you will find the mid element. So the mid element is 3. You will return you'll see that it is not true. Then what you will do is you will check whether it is ARR of MID, which is your 3, is greater than X. So it is not greater than X, it is smaller than X. So it will go to this part, and it will give you the values. So again you will start checking for this particular array, and you will find the 10 here. Okay, so this was about it. If I just run it out, you can see it will give me element is present at index 3. If I change it For suppose 3, it will find it in the very first iteration. And you can see it is giving me index 1, right? Similarly, in the iterative method, you have to assign your low, high, and mid. Similarly, again, so I'm assigning my low, mid, and high by default. So low is 0, mid is 0, and high is, we know that the length of ARR minus 1. Okay. So while low is greater than high, because we are looping through the elements, we will be changing the value of mid. Same logic we'll also implement here. Just the thing is, here we were using recursion, and here we'll be using the loop to do that. So instead of doing recursion, we are just following the loop here. And in the loop, I'm just implementing the same logic, that if it is on the lesser side, we will increase the value of mid. If it is on the greater side, we'll decrease the value of mid. Okay. And if by default we do not get anything, then we'll return -1, which is implementing that there is no particular element as such, right? So if I run this out for this also, you'll see that I'm getting index 3 since I'm searching for 10. And for 4, if I search, suppose I am getting a 2. All right. So this was the end of the video, and I hope that you've understood the question. And I'll see you in the next video, guys. Till then, take care and bye bye.